In this tutorial, we want to create a rotation limiter. I must admit, this tutorial gave me quite the headache. I did not include rotation limiters in my original build, and before starting this tutorial, I had several implementations that I was not really satisfied with. And it is very likely that the limiters we will create now will also need to be altered in the future. But for our current purposes, that should work just fine. We will create an abstract rotation limit handle that exposes one limit function. We then implement a rotation static limit handle that defines a zero elevation plane, and every vector within this plane can be used as a reference vector for a 0 degrees rotation. This class will make sure that a provided rotation will stay within the maximum and minimum range. Mock implementations can be used for testing. And finally, we then can plug in a limiter into a rotation controller to enforce those limits. We start off by creating the script file and the test file. Then we define our RotationLimitHandle as an abstract class and add an RotationStaticLimitHandle which implements this abstract class. We define an abstract limit function. It receives an angle that tells us how much we want to rotate, the current offset to the rotation point, and a rotation axis. The function then returns a corrected angle. Our implementation will now simply throw a not implemented exception. Our first test will make sure that we enforce a certain maximum limit. We instantiate a limit handle and define a horizontal plane as the level plane. We do that by defining the normal of the plane as vector up. We also define a maximum rotation of 30 degrees. We then attempt to rotate 45 degrees. Our offset will be a vector forward, which lays within our level plane, and the rotation axis will be vector right, so it is a vertical rotation. We then assert a returned rotation of 30 degrees. Before running the test, as always, we need to add our missing fields. The test fails with a not implemented exception, but returning a dummy value will cause the test to fail at our assertion. For now, let's just return the maximum rotation. The next test will make sure that we return the provided angle when we are within the allowed range. We solve this by comparing the angle and the maximum angle and return the appropriate value. In the next test, we will set our offset outside of the level plane. We want to rotate 20 degrees. But our offset vector will be 0, 1, 1, which means that we already rotated 45 degrees. Adding 20 degrees would mean we end up with 65 degrees, which means our limit function should return 15 degrees, so we end up with 60 degrees maximum. And of course that fails. So now we need to find a useful vector that is within our level plane. Let's say we have a vertical rotation plane, which is defined by its rotation axis. And we have a level plane, which in this case is defined by the upward vector. We now need a reference vector that exists in both planes. We use this vector as a reference for a 0 degrees rotation. This kind of vector can be retrieved by using the cross product of one vector with another. And Unity already provides such a functionality. We now simply use this cross product between the level plane normal and the axis. And now we can use the level vector and the offset vector to retrieve the current rotation angle. Then we add the current angle and the provided angle together to get our target rotation. And now we simply compare the target angle instead of the provided angle with our maximum angle. If the target angle is too big, we return the difference between the maximum angle and the target angle. This test failed. The position of vectors in a cross product is important, so we simply swap them out and try again. We also want to set a minimum rotation. We set a minimum of 20 degrees and we will use our 45 degrees offset and rotate minus 30 degrees. That means we would end up with 15 degrees rotation. Consequently, we should only return minus 25 degrees. We add the missing value and run the test. And in our implementation, we simply compare the target angle not only to the max, but also to the minimum value. And for now, this component is finished. But we must be aware that this component only works for positive angles smaller than 180 degrees. I used a mock class to test the integration of LimitHandle in a RotationControler. Its limit function simply returns a predefined return code, and it also records the supplied parameters, which allowed me to write tests that only test against this predefined return code or the supplied parameters of the limit function. The RotationControler then simply uses this limit function to retrieve the restricted angle. The source code can be found in the repository. Now we can update our rotation prefab with a limiter. First, we create a menu item for our handle. I also changed the file name from RotationLimitHandle to RotationStaticLimitHandle because Unity prefers that the names of scripts match with the names of components. We then create the handle to limit the vertical rotation of the camera, and I choose 80 and 20 degrees. And then we simply plug it into the vertical camera rotation. But that's it for this tutorial. Next time we will create a small component that makes sure that the player always faces away from the camera when moving, so that while standing we can rotate around the player, but when moving we always face away from the camera. Let me know what you think, and thanks for watching.